So, you're welcome to the class of Math 232, that is elementary differential equation. First, what is a differential equation? When we mention a differential equation, we're simply talking about something. First, what is a differential coefficient? If I said differential, I'm simply saying differentiating something with respect to another thing. So this is very much applied in sciences, in economics, in biology, DNA stuffs, and molecules. So when I say differential or the differential coefficient, it simply means the derivative of something with respect to another thing. If this is y and it is equal to f of x, y is equal to f of x. That means y is a function of x. The y, the x, is going to be the derivative of y. The derivative of y with respect to x. What does that mean? That means we are differentiating y. That means it is the differential coefficient of y. Now, a differential equation now is an equation that involves the dependent variable, which is y. You can see y is depending on x. Without x here, we can't get the value of y. If x is 1, we can get y. If x is 2, we can get what y is. But without x, we can never get y. So x is independent variable and y is dependent variable. So a differential equation is an equation that involves the independent variable. The dependent variable is y. It involves the dependent variable, the independent variable, and the derivative of the dependent variable. That means the y, the x. So any equation you can see the y, the x, or the anything, the another thing. That means differentiating one quantity with respect to another quantity. Anywhere you can see that, you say that is a differential equation. So this is a very common one gotten from wave and oscillation. dx squared dt squared plus omega naught to the second power x is equal to 0. This is the equation of oscillation for a pendulum bulb and normal spring as well. So where omega squared is what it is. That the x squared over dt squared plus omega squared x equals to 0. We already have an equality sign, which makes it an equation. We are having the x. X here is the dependent variable. T is the independent variable. Everywhere, the independent variable is the one below whenever we are doing differentiation. The independent variable is below and the dependent variable is above. So the dependent variable is x here, independent variable is t. And now see, we're already saying the x squared is t squared plus omega squared x is equal to 0. So this is a differential equation. So when we say differential equation, this is simply what it means. So there are many examples of differential equations and they are applied in everyday life activities. So if I had something like this, this is d dx of xy. If you differentiate this, what are you going to have? I'm going to use the product rule because this is a quantity, this is another quantity. That is x dy dx plus y dx dx. That is what we call the product rule. V du dx plus u dv dx, where this is u and this is v. I suppose you've passed through the product rule. So this is x dy dx plus y because dy cancels the x. So this is not a differential equation. Why? Because what is at the right side is equal to what is at the left side. We only simplified what is at the left side to get what is at the right side. So this is not a differential equation. It is simply called an identity. So you should try to recognize and identify differential equations.